Welcome to Mr. Hamilton's Math Bites. This video is on arithmetic sequences. Our goals for this lesson include the following. Know the difference between discrete and continuous functions. Determine and describe a recursive procedure for an arithmetic sequence. Identify if a sequence is arithmetic given a numeric or algebraic representation. And, given two term numbers and their values, find the initial value and the common difference. A sequence is simply an ordered list of numbers. So for example, 3, 11, 9, 19, 27 is a sequence, and that continues to go on. And this is a relatively simple sequence to figure out how it follows from there, because I hope you'll notice as you just think about that for a minute that I'm adding 8 every time. So if I continue to add 8, I'm going to be able to find the next two numbers. If I add 8, I get 35. If I add 8 again, I get 43. So the next two numbers are 35 and 43. Now if I asked you to graph the term number versus the term value, we would get the following. Our term number is 1, 2, 3, 4, 5, 6. We've got 6 terms here. Those are called the term number. So 3 is the first term number, the term value of term number 1. 11 is the term value of term number 2, etc. So if we graph that, we're going to see something happen here. If I go up here by 1 on the x-axis, that x-axis is actually going to be represented by the term number, which we're going to give n. The term value we're going to call t with a subscript n. That's a little value in the corner. That's not a big N. On the y-axis, we're going to graph that t of n. And starting at 0, we're going to go up by 5s on this axis. And this should fit nicely for us. So term 1 has a value of 3. Term 2 has a value of 11. Term 3 has a value of 19. Term 4 has a value of 27. Term 5 has a value of 35. And term 6 has a value of 43. And so if I go ahead and I graph a line between those values, what I'm going to do is I'm going to see something that looks maybe not like that. I'll have to move that line. See if we can get it to fit nicely. Wait for it. Joys of using computers. There we go. Now that line is not actually representing the function. The line is just showing the trend. Really what we have is the only points this function actually exists are at these dots. The function only exists at the dots. The line just trends. The line just shows the trend. So what we have here is this is a discrete function. It only exists at specific values, specifically the dots. It does not exist at every other point along the line. In grade 9, you graphed a linear relationship, and you're very familiar with this. And if we continue this linear relationship along, we can go back here and we can see that this is actually going to go through the point at -5. And what you would say is you could represent the formula as the y value, in this case Tn, is equal to mx plus b. And so m is your slope, and your slope here is going up by 8, and your y value is -5. So you would say it's 8n minus 5, right? That's your slope, and that's your y-intercept. But as we think about this idea of discrete functions, and specifically as we think about arithmetic sequences, I want us to look at it from a different perspective. And the perspective is this. Notice that every term, every number in the sequence is 8 more than the previous number. So let me write that sequence for us again. 3, 11, 19, 27, 35, 43. So everyone is 8 more than the previous number. So I'm going to write that out a little differently here. Instead of writing specifically the term value, I'm going to write it out as a sum. And so the sum is going to look like this. The first term value is 3. The second one is 3 plus 8. The next one is 3 plus 8 plus 8 again. And that pattern is going to continue. And so what we have here is we have a number of 8s that's added to the 3. That's 1 less than the term number. The number of 8s added to the 3 is 1 less than the term number. So that leaves us, remembering that the term number is n, with this expression. We're starting with 3, and we're adding the term number minus 1 8s. Now we can expand that. That gets 3 plus, and we use the rainbow rule or the distributive property as it's more mathematically pronounced, as 8n minus 8, and then that simplifies to 8n minus 5, which is exactly what we had from doing it above. However, we're going to find that this method, specifically this right here, is going to come in very useful for many of the questions that we're doing. Specifically, the general term for an arithmetic sequence is this: Tn equals a plus n minus 1 times d, where the appropriate a and d value are substituted. Remembering that a is the initial value, or the starting value, and that d is your common difference. Now I've said that n has to be greater than or equal to 1 because I can't have an n value that's negative, because n refers to the term number. So I always start with the first term and count up from there. Let's do an example to see how this is useful. What is the 25th term of the sequence 2, negative 1, negative 4, negative 7? Well, the first thing we recognize here is that a is 2, that's the starting value, and d, the common difference, is negative 3. Well, how did I find that? Well, this is, I think, a fairly obvious example where I can just say, well, if I subtract 3 every time I get that. But in general, if it's not so obvious, what we can do is we can take the second term, or the later term, minus the first term. So negative 1 minus 2 gets me negative 3. Then I'm going to take the third term minus the second term. So that would give me negative 4 minus negative 1. And if you subtract a negative, it's like adding it. So you get negative 3 again. And negative 7 minus negative 4 is going to give me again negative 3 because we add the 4 to negative 7. That leaves us, if we're trying to find the 25th term, with the n value being 25. So we take our general term, which is this, and we substitute in those values. The 25th term is what we're after. We want to find out what this Tn value is. So 25th term, the a value is 2, n is 25, d is negative 3. And when we expand that out, 2 plus 24 times negative 3, we get a value of negative 70. So that means that the value of the 25th term is negative 70. And we didn't have to write it out so we get 25 total terms. We were able to jump ahead and do that. That's the beauty of the general term. The recursive formula works a little bit differently. The recursive formula is a formula that you need to know every previous term to determine the next term for. Here's the definition that I typed on the page. These are the formulas that give one term value based on the previous term's value. For example, if you want to find the 5th term's value, given the first term, you also need to find the 2nd, then the 3rd, then the 4th terms. Recursive formulas are fundamental in computer programming, because you might wonder, why would we care for this? when I've learned a shortcut to find this all the way to the 25th term. And that's the reason. These are absolutely fundamental when it comes to things like computer programming. And they'll also creep up in other areas of mathematics as well. So, for arithmetic sequences, the recursive formula is this. T1 equals A. So in other words, you're given the first term, T1, that is the first term value. And then the next term is equal to the previous term. That's what Tn minus 1 means. Plus that common difference. And then the restriction here is that n has to be greater than 1. The reason it has to be greater than 1 is this right here, the n minus 1. If n was 1, then you'd have t of 1 minus 1, which would give you term 0, which you can't actually have. So the n value is going to be 2, 3, 4, 5, etc., but never 1 or less. So let's see. If t1 is equal to 3, and tn is equal to tn minus 1 plus 8, find the next three terms. So again, this is our starting term. That's our a value. And again, this 8 is our d value. We're trying to find the next three terms. So t2 is equal to tn minus 1. So it's t of 2 minus 1 plus 8. Well, 2 minus 1 is t1. And t1 is, we're told, is 3. So that's 3 plus 8, which is 11. Then term 3 is equal to term 2 plus 8. And term 2 is 11. 11 plus 8 is 19. And then term 4 is equal to term 3 plus 8. Well, term 3 we just found to be 19. And the next term ends up being 27. And that's exactly the sequence we found in our first example. Take a minute, just review that, make sure that all makes sense. And when you're feeling confident with that, let's move on and look at this last challenging example. This is very different than what we've looked at so far. And this is a situation where we're finding A and D given two term numbers and their values. Here's the example I have. The 20th term of an arithmetic sequence is 45. The 37th term is negative 6. Find the general term. So what we know is that T20 is equal to 45, and we know that T37 is equal to negative 6. That's all we know. We're not told the first term, so we can't start with that or anything. Now there are two ways to do this. The first way that I would recommend is probably the shortest way, but it might not be the most logical to you. And I would call this method simply using reasoning. But again, maybe the other way to do it is more reasonable to you. How I would do that is I would take term 37 and subtract term 20 from it. So term 37 is negative 6, and I'm subtracting the earlier term from that. We know that it's arithmetic, so it's going to go up by the same amount each time, and that's why I'm allowed to do this. So that gives me a difference of negative 51. Once I know that from the 20th to the 37th term, there are going to be 17 terms. And if there are 17 terms, then I can say 17 times that common difference is going to equal the total difference between those. 17 times the common difference is negative 51. Then I just solve that for D, and I find that D is equal to negative 3. Now we know D, but we don't know A, and we need to know A to find the general term. And so to do that, what we have is that the general term is A plus n minus 1 times D. And so if we substitute term 20 in here, the A value we're looking for still, but if we substitute T20, that's 20 minus 1. The D value is negative 3. I get 19 times negative 3, and that gives me negative 57, or A minus 57. And I know also that term 20 is 45, has a value of 45. So solving for A gives me 102. And then I can write my final term out as follows. The general term is Tn equals 102 plus n minus 1 times negative 3, which we can expand and simplify. Both are technically correct. The second method is two equations with two unknowns, and we'll look at that in